Now, last day we didn't have time to finish this problem. Let's finish it now. Let me remind you what the free body diagrams for A and B look like. B had just a weight force and a tension force, and this diagram had to screen 0 because we were told that A was moving up the frictionless ramp at constant velocity. Well, that means that B is descending at constant velocity. Our free body diagram for A, we had a weight force that we were told was 50 newtons. We then had a normal force by the ramp, and we had a tension force by the string. There was no friction, it's a frictionless ramp. Now if we line up our coordinate system with our ramp, all the forces are lined up with our coordinate system except for the weight. It's always the weight. Now I've had a lot of people come into my office with free body diagrams, and more often than not, they've broken this up incorrectly. Now if you break this up incorrectly, you're dead in the water. So let's do it the right way. Look in the direction of the normal force, go the other way until you can make a 90-degree turn. There's the 90 degrees right there to get to the end of the vector. This is going to be the y part of the weight, that's going to be the x part of the weight. If you do it that way, this angle here is going to be the same as the angle of the hill. Now if this is 50 and this is a 3, 4, 5 triangle, 3, 4, 5, this has to be 30, this has to be 40, 30, 40, 50. I throw away the original and I use the parts. If A is moving at 0 acceleration, constant velocity, this diagram has to be balanced in both the y and the x direction. In the y direction, what I'm calling y, this has to balance that. It has to be 40 newtons. In the x direction, what I'm calling the x direction, this has to balance that. It has to be 30 newtons. Because this is the other end of the massless string, by the law of massless strings, this is also 30 newtons. And that makes this 30 newtons, which means the mass of B is 3 kilograms. Now clearly the mass of A is 5 kilograms. Now when this was on an exam, some of the students were troubled that a 3 kilogram block could pull a 5 kilogram block up the ramp. Well, I have here a cart whose mass is 502 grams. If I take 100 grams, well, this is 1/5 the mass of that. And yet it doesn't bring it up at constant speed, it speeds it up. Okay? This weight doesn't have to cancel out the weight to go at constant speed. It just has to balance this part of the weight, the x part of the weight. Now what that means is that if I have a horizontal track or a frictionless table with a pulley, there is no horizontal part of the weight. So that means I could have the Queen Mary, the great big huge ship on this frictionless table, and if I hung just a little teaspoon from the captain's table over here, it would accelerate the Queen Mary if it's a truly frictionless table. There's no friction to hold it back. There's a net force this way. It's going to accelerate. Okay? Now, in this problem, the part we didn't get to was as this thing is going up at constant speed, a hand stops it. And then lets go. And the question is, what is going to happen to the block A? After the hand lets go, will the block move up the ramp? Will it stay put? Or will it move down the ramp? With your clicker, tell me what you think will happen. Okay, let's go. Okay, move up the ramp is what one. Well, the answer is B, it will stay put. This diagram is balanced. When the hand stops, block A, it stops it by putting a retarding force here, force by the hand, to slow it down to a halt. But when the hand is removed, I go back to the exact same free body diagram that I had before. A diagram which is balanced that screams acceleration 0. Now acceleration 0 means whatever velocity you got, keep it. If your velocity is 5 meters per second up the ramp, keep that. Okay? If it's 0 meters per second up the ramp, you keep that too. Okay? And so it turns out that with 50 newtons, I can get this thing to go at a constant velocity, pretty much a constant velocity. Okay? And if I stop it and then let go, it just stays there. It has 0 acceleration and 0 initial velocity. It keeps that 0 velocity. Check that your neighbor's okay with that. The answer is B, stays put.